Ladies and gentlemen, I am honored to welcome you all to Massey College for this second Ursula Franklin Science Forum, second annual Science Forum. We are on the traditional lands of the Huron-Wendat, Ojibwe, Anishinaabe, and Haudenosaunee, and more recently the Mississauga of Credit, who are our partners in Chapel Royal, and whose flag actually flies from the college flagpole today as we gather here for this important conference. We are really deeply committed to science as part of the interdisciplinary approach that has always defined Massey College from its very, very beginning. And the notion that we would have named this after Ursula Franklin is particularly apt. I did not get to spend many years here at the college with Dr. Franklin, but she did come to see me, I think, the second day I arrived to let me know what the core priorities had to be, and she was clear and precise, and in her own way, very, very gentle and very, very thoughtful. But I thought one of her quotations was particularly appropriate for the discussion of artificial intelligence. Ursula said in her work as a physicist, as a metallurgist, as a philosopher, as a pacifist, as someone who used science to make the case for non-proliferation in a very deep and compelling way, she said that peace is not the absence of war, peace is the absence of fear. And while all of us would be united in our aspirations for AI, its ability to, in so many areas, medical science, the hard sciences, intellectual work, a whole bunch of fundamental areas where our society operates, embrace, promise, and the opportunity, there are a lot of folks who are actually quite frightened about what it may do. The marketplace, what it might do to jobs, what it might do to the regulatory framework, what it may do to the way in which we manage things like ethics and the whole decision-making process, which is not driven by neural networks and the rapid gathering of massive amounts of data, but by other considerations, at least this far. So a session like this, which is about understanding, talking about the different issues, getting them on the table as a way to combat fear and get us back into the territory which I think all of us prefer, which is the territory of hope. And I just want to say that when you drop out for coffee for a moment or leave, you'll find on the table the Henry Friesen International Prize Lectures, number 10 and number 11. Dr. Bernstein, of course, is the most recent Henry Friesen laureate. Paul Nurse and Janet Rossett are the authors of the two pieces of scientific work, one on the fundamental significance of discovery science and the creative process, and the other by Dr. Rossett on stem cells and genome editing, ethical challenges in human health. It's all part of the broad science commitment here at Massey, so please make yourselves at home and take one of these and enjoy them. And it's now my great privilege to call on Barbara Sherwood-Lawler, who is the chair, actually, of science here at Massey, to say a few opening words.
Thank you. It's really a very false advertising to have me stand up here. I serve, as we all do at Massey, in support of the junior fellows and the fellows and alumni. And really my role is simply to try to provide some advice, help here and there, and in the end I have probably learned more about how to organize a superb conference from the wonderful junior fellows who and alumni who participated in the organization of this. I'll introduce them in a moment. But I wanted to start first by welcoming you all to Massey, if you're part of the Massey community, back to Massey if you visited before, and to Massey for the first time. This is indeed the first time you joined us for one of these events. I think as Hughes mentioned, and as Ursula minimized, they are able to reflect in a very few words the really insightful, thoughtful, and thought-provoking nature of the Massey community. The quote that you came up with, I think, is perfect. For Ursula, she often had a habit of saying, "Are we asking the right questions?" And by doing that, I think it was always able to shine an interesting light on something that we're thinking about or beginning to. So this particular enterprise today with the panelists, we're very much looking forward to the entire topic that's going to be grappled with today. If we could go back to the one slide on the overall introduction to the conference. Again, this was led and devised by the junior fellows and alumni fellows of the college. They met, brainstormed, 27 potential topics later, they came up with 2 they decided to focus on. The one that's taking place today on AI, and there'll be a second event on March 19th in the evening on green energy. So if you enjoy this one today, definitely come back and join us for the second half of the week's work that will be taking place on the 19th of March. With all of the Science at Massey events, they're very much meant in that inclusive way. These are not just science events. We'll be talking about science, we'll be talking about technology, but we'll also be talking very, very much about the interface of science and technology application and human interest in these topics. So that's very much reflected in the kinds of things that we try to do. A couple of quick housekeeping items. If you're looking for washrooms, please take a break at any time. You can reach them through there or by going out this door and around. They're just close to the cloakroom. There's also accessibility washrooms located on the lower level. Please be aware this entire event is being live streamed, so the audio as well as cameras are present in the room. If you want to avoid being captured on video, you just need to know where the camera is and sit somewhere where it can't reach you. Feel free to tweet throughout the day, and we have a Massey, there we are, tweeting, and a link for the video as well if you'd like to enjoy this in an hour or afterwards. And with that, my job simply becomes to introduce the 4 members of our committee who are co-chairing and running the event today. And that is CU, postdoc in chemistry, Jesse, PhD in physics, Amir, PhD in political science, and Charlie, master's student in information. And they will be conducting and running this talk. So I'd like you to join me in thanking them for all the hard work that they've done here today. And we hope to see you to start.
So, thank you all for coming. So just to give you a quick overview of how the day is going to go. Format of this event will be 2 panels. So we're going to start off with a topic of how to use AI intelligently. And then in the later on in the afternoon, after a coffee break, we're going to discuss how to use AI safely. So each panel has 3 or 4 speakers, and they will each provide opening remarks. And then we've provided some prepared questions that they will discuss. And then we'll open it up to the floor to everybody for a nice discussion. And since we are, so as part of the Science at Massey kind of code of conduct, we're dedicated to providing a harassment-free environment for everybody. So we just like everybody to be respectful in terms of the questions and the discussion part of this event. So with that, I think I'll ask Jesse to come. Actually, no, before I introduce the speakers, maybe I'll tell you guys a bit about what we were thinking about doing with this first panel. So it's titled How to Use AI Intelligently. And so we'd like to address the question of, in our research, when is AI an appropriate use? How is it advantageous over traditional methods? What types of problems can be addressed using AI? How do we use that in different fields? So of course, my background's in chemistry, Jesse's in physics. What about in social sciences, where Amir is doing some research? So to help us answer these questions, we've invited our speakers from 4 different fields of study or work, and they'll approach it from their own perspectives. So with that, I think Jesse can introduce the speakers, and we can get started with the presentation.
Once again, thank you all for braving the winter storm and coming today. In a moment, I'll ask each of our 4 panelists to give some opening remarks about what they're doing. First, let me just introduce, starting from the farthest, we have Charlie Jaiswal, who's a machine learning scientist at Integrate AI. She was also a junior fellow of Massey College while she did her master's here at U of T. Next to her is Mukti Rahman, who's a research scientist now working in the Canadian Institute for Theoretical Astrophysics here at the University of Toronto. Beside him is Professor Ludwig Rowe, an assistant professor in political science here at the University of Toronto. And right next to me is Professor Jonathan Rose, professor of electrical and computer engineering, also at the University of Toronto. So please welcome Charlie Jaiswal, who will start off our panel.
Great, thank you all for joining us today. Can you all hear me? Perfect. So the organizers asked me to open up with maybe a few comments about putting AI, artificial intelligence, in human terms or terms that are more relatable. I think of recent, you've probably heard a lot of buzzwords, artificial intelligence, robotics, reinforcement learning, all these things. But I think if we can communicate it in familiar terms, you can say artificial intelligence or this kind of area is the intersection of computer science, some recent developments in hardware, mathematics, be it statistics or probability theory. And the reason I think you've really heard AI become more apparent or being used more of late is because of a lot of recent developments in computer hardware. So we used to have, the problem, a lot of these technologies and areas of research have been around for decades. But the uptick kind of happened because all of a sudden we were actually able to analyze all this data because we have GPUs, which are a type of hardware in terms of computing, that are so much more powerful. So now we can access data from devices or the internet and analyze them and produce predictions, et cetera, in a very quick amount of time. And I work at Integrate AI. We are an enterprise company that basically our goal is to make delightful customer experiences. We're not trying to use AI in a predatory way. We want to enable corporations to make better customer experiences. And so there's a lot of discussion in our company about privacy and ethics and whether we're trying to promote a product or target customers. We're never after selling something or promoting something that someone would want. We want to create the best customer experience for people. And my work is on the more applied side. So the other panelists here will maybe talk about more the theoretical terms, but in industry, I think the key pillars that a lot of companies are thinking about are privacy and ethics. So we have access to a lot of data, but how do we use it in a responsible way? How do we prevent breaches and things like that? How do we scale our processes? So, it's one thing to run an experiment or create something on a very small size data set, but how does Google, for example, run all of its processes on, billions of gigabytes of data, for example? So privacy, scalability, and then again, tying it back to creating delightful customer experiences. So those are kind of the things that I think about when we talk about how to actually apply AI or actually how to use it in the industry.
Thank you, Trevor. Mufti, would you like to open?
Sure, thank you very much. So my background's in astrophysics. I am interested in how to use the large data sets that we're getting from telescopes all across the world to try to tell something about the physics of what's going on within the objects that we're looking at. And a classic problem has been, this is about a century-old problem now, is you can look at a number of different objects in space and you see that their structures are very different. For instance, one of the more fundamental ones is, if you take a look at galaxies, they broadly break down into 2 or 3 different categories. There are these spiral galaxies that look like spirals, as such named, and these things that are elliptical galaxies, and they look like blobs. We've seen these things for longer than we've even known what they are or how far they were. For the record, this spiral galaxy is very similar to what our Milky Way looks like. This is something that we only started to recognize back in the 1930s and 1940s. The challenge of this, however, is this identification has always typically been done visually. That means an astronomer or a human being of some sort is sitting down at a picture or a photographic plate originally, or moving on to computers and looking at that image and deciding whether or not that is a spiral or an elliptical. Which way is it turning? Is it going clockwise or counterclockwise? And all of these things matter because it tells us something about the life state of this object. Galaxies are the building blocks of the universe. And so the structure that we see tells us, for instance, has it eaten up a smaller galaxy in the recently? Has it, formed new stars recently? All these things are related to its shape. And that's not a parameter that has easily been calculable just using traditional methods of sticking a spectrograph on it and trying to automate that. So one of the things that we've done over the past decade or so has been tried to use what's known as wet neural networks, i.e. human beings much like yourselves, to try to do the classification for us. And that's created a process, or a site called Galaxy Zoo. So this is something that you can do yourself. You can go online to Galaxy Zoo, and they'll train you for about 4 or 5 different galaxies to try to point out individual features. And then it'll send you off into 500,000 different galaxies that we've observed through telescopes and ask you to try to classify it. Millions of people on the internet have been doing this for approximately a decade at this point. So we have classifications for each of these galaxies. Now this is great, even for a data set which is about 500,000 pictures. People will look at 500,000 pictures. People will not look at 500 million pictures. People will not look at 1 trillion pictures where that picture is looking very similar every night. And this is the challenge that we're running into today. We're now having a number of telescopes that are coming online that are going to be looking at the night sky every 3/4 of the night sky every night. In terms of data terms, that's about 3 or 4 terabytes of data every night. It's going to be streaming from the telescope through, in Chile, into places like Arizona and Washington State, that there's no human set of humans that can do this for us. Secondly, humans tend to be highly biased in the way they see things. For instance, a known correlation between galaxies is that spiral galaxies tend to look blue, and elliptical galaxies tend to look red. You tell a human this, and they'll start looking for that signifier. They'll start looking for something that's red or blue. And that is a bias that's implicit, that starts to become implicit in the data set. This is one of the reasons that we want to use something that's a little less biased, or at least we can control the biases. And that's where AI comes into it. But this is a bit of a challenge. The benefit is we now have a fantastic training set. People have now classified about a half million galaxies. And they have images, unfortunately it's a little dark here, but this is what the images look like. They're actually not particularly easy. The previous slide where I showed you, sorry. Let me go back, sorry. Previous slide, these are some of our closest neighbors. We can see them in their full spectacular delight. But we get to some of the more distant ones and potentially some of the more interesting things that tell us about an earlier state in the evolution of the universe. They start to look like just fuzzy balls of gas. And it becomes more critical to try to make sure that our biases of what color they should be, of what they should look like, don't start to interfere. So what we've been doing is been trying to use the galaxies that we know and love that have been classified using the wet neural networks or human classification to try to figure out, A, can we do a good job of classifying any of these new galaxies that are coming through the pipeline? And most importantly, what are the biases of these networks? What are the implicit problems that we're seeing that we know that there's a correlation that has nothing to do with its shape, but the neural network or the convolutional neural network picks out that it shouldn't, that we don't want to bias ourselves for. So this is what we've been working on. Thank you.
Thank you, Ludwig.
Yes. So very interesting. I'm going to talk from the perspective of social sciences, so quite different. And I should start by mentioning that AI is maybe it's an elastic concept. So I'm not quite sure that everything from the field of AI would be useful for social sciences as it is now. But what we're using, what we see that could be very interesting opportunities is the use of machine learning. So some components of AI have become very useful for doing social science research. The kind of things that we're doing in social sciences are not as perhaps utilitarian as in engineering, computer science. We're not trying to build applications, although some of my students are doing it. But what we want is understanding the world. So I see a connection from the previous presenter. They're looking at the start, trying to understand how it works. Well, we do the same thing with human beings. So the goal is usually to test theories, understanding how people think about politics, whether they will go into conflicts. So understanding conflicts, of course, in political science is pretty important. Now, how does machine learning change the way we do research, or can change the way we do research in social sciences? The way I would summarize that is very technical. So if you have statistical models have been used a lot in the social sciences, usually you have data sets that are very standard. Say you do a survey, we use survey data a lot. You have observations, you interview 1,000 people, you have different variables for each of them, and for each observation, you have these different variables. So your input is a matrix. It's a two-dimensional matrix. What has changed with machine learning and AI, especially because they were trying to process images, which are in 2 dimensions, is that each of your observation can have a complex input, a complex type of input. For instance, if you have a 2D input, then we're talking not about a design matrix as we used to call it, but we're talking about tensors or multi-dimensional arrays that constitute your input data. So we're able to process that. What that means for social sciences, I think the most the simplest example is textual data. So everything that happens in politics happens through language. And before, just a few decades ago, it was almost unthinkable to process what's been said. You would have to go through everything by hand. It would take, I'll give you a concrete example of that in just a second, how long it can be to actually follow and track what politicians are saying. And just following what's happening seems pretty important. So what we can do with machine learning, for instance, is much more efficiently being able to process complex forms of inputs and predict things like what's the ideological stance of a speaker. That's a main agenda, a research agenda that I have and that some of my students have, how people think or feel about issues, about leaders, about issues. We have the data. So before, just a few decades ago, when I started doing political science research, you would, if you wanted to do a survey and have an idea of what people think, and that's the goal of politics, we should make decisions that reflect what people think. So we'd have to survey them. It would cost hundreds of thousands of dollars just to field a survey. The cost have decreased because we do them on the internet. But now we have the data. People are willingly expressing themselves online. Tell what do you think. I have some piece of data. So 200 billion tweets a year are posted. There's 600 terabytes per day of data posted on Facebook. That's a lot. That's 600 terabytes. They have the probably it could help you to process the data. There's 4.6 billion web pages, a large quantity of blogs. So people express themselves. So we can process that efficiently with machine learning. We train a model, and then we have an idea of what people think. And yeah, again, it may not be as utilitarian of thinking, well, perhaps, well, there are lots of ideas for commercial applications, but it's more about, for us social scientists, to understand what's happening, what people think, how people react to different events. So, for instance, I'm following public opinion in real time using Twitter data, and I can look at what happened when Donald Trump announced a decision like the travel ban. How did people react before and after? The reaction of different groups, understanding how people, whether opinions are changed or moved depending on events that happen in politics. Just to give you a final example, I don't know how long I should have timed myself beforehand, but give you a concrete example that, of what can be done with machine learning and social sciences. So my research team have produced a database of all the speeches that have been uttered in the Canadian Parliament since 1901. So more about 115 years of data digitized. It's a corpus that contains over 3 million speeches. One of my colleagues estimated the time it would take for a human being to read through all of this, and it would take over 60 years to do that. So you have the choice: either hire a research assistant that waits 60 years so that they have read the whole thing, or we can use, which is what we did. So for instance, a simple task, we just wanted to isolate all the speeches about foreign trade. For a study about foreign trade, we trained recurrent neural networks that can process sequences of text and take into account the ordering of words, which is what we do when we want to understand language. We need to, there's a meaning to the sequence of words. So that's an example of complex type of data input. And using that, we're able to predict with an accuracy of 99.3% whether a speech is about foreign trade and avoid confounding with by the way, it's a difficult task because there's also trade, the professional people like mechanics, there's also retail trade as a sector of the economy, there's interprovincial trade. You don't want to confound that if you're interested in foreign trade. So for a human being, it's easy to do, but it would take years in order to go through the database, and we can do it in hours with machine learning. So that's just the tip of the iceberg. I think I've only scratched the surface of what we can do to understand our world using machine learning in particular. There are other things like knowledge representations that are also important for AI that I didn't have the time to address, but that I think will play a role in the social sciences. But we can get to that when we open the discussion. So I'll leave the microphone to my colleague here.
Yes, please, John.
Oh yeah, sure.
That's really interesting. So some overlap with what I was going to talk about as well. I came to machine learning, a subset of AI, because of an interest in the automation of medicine. I think it's time to think about that seriously. And here's why. I think, and I'm not sure everybody agree, that 50 years from now, you will get a lot of your medicine from a computer. I don't see any reason why you couldn't describe your symptoms to the computer. It would receive that, and it would receive the data from accurate machines that would be relatively objective. It seems clear we could turn that into a diagnosis with enough data and training. And why not prescribe medicine? Scary now, and prescribe treatments. Scary now for a machine to control that. Maybe not in 50 years. I mean, gosh, we're driving cars these days. I think it's a really important goal that's already underway because we've just hit this state of hardware and software and medical technology that is enabling this. And AI, and in particular machine learning, is really one of the keys. And so that's why I've actually I'm on sabbatical this year, and I decided I needed to become literate in machine learning. So this is new to me. It's not nowhere near my regular field. Talking about the automation of medicine is ridiculously broad. You can't do research on that. And so my focus actually has been a little more narrow on mental health, in part because I think it's one of the most underserved fields in medicine. There just aren't enough people helping in that. And I should say, I'm going to give two quick descriptions of some projects I have on the go. Of course, I know nothing about medicine, so this is all done in collaboration with clinician researchers, people who are on not the front lines, but also do research. So one example that involves AI a little bit, I think, is a great idea that someone else had, I think, which is you should be able to infer severity of mental health disorders from just picking up all of the data that your smartphone throws off. Your smartphone throws off tons and tons of data. It knows where you are. It knows your physical motion. It knows how much light is around you. It knows your activity on the phone. And it knows the messaging you're doing. And there's a microphone there. So we have an app actually now with ethics approval here from the University of Toronto that is an Android app that does in fact deliver all of that into a server, including sampling 10 seconds of audio every 5 minutes. If you want to have a deep ethics question, we can get into that. I can tell you how we got through it. We have a particular focus on social anxiety disorder. It's a disorder where you're essentially afraid of judgment to the point where you can't do much, and you hide from people, and so you can't function. And so we would like to be, we have experiments up right now, and we're trying to recruit more people into it. We're trying to infer the level of, on a standard scale of social anxiety using machine learning techniques. Now, that's maybe too big a hammer to do something that might even be, it seems almost obvious to me that we could look at the GPS location if you're hanging out at home, well, we're done. You know, we know that you're suffering badly, but actually I think there's deeper things to infer from that other data. So I think that's an interesting application of machine learning. The second one I want to talk about is related to what we were just talking about. We were just talking about making use of natural language processing. And this is in collaboration with the folks at the Nicotine Dependence Clinic at CAMH, and in the area of addiction. So, and most particularly in helping people quit smoking. And actually a key first step to that is convincing someone who's a smoker that they actually want to quit smoking. Before you even try, you have to want. And so you have to make that decision. And so our project that my collaborator suggested is a chatbot that talks to you about this. A chatbot is a computer that talks to you, either through text, or I suppose these days we can do it with actual language, actual speech. But we're focusing on text, so you can kind of see it. Can't see too much of it. And the goal is to walk you through a reflection using a known clinical technique. It's called motivational interviewing. That is a structured conversation that helps you reflect on smoking and perhaps take you to that decision that you do want to quit. Everybody knows it shouldn't do it. Nobody really, the vast majority of smokers haven't taken that step. And we are making use of this major advance, I think is really just in the last few years, of natural language processing that allows a machine to correctly classify what is being said by humans, which was traditionally quite difficult. We speak in many different ways, different meanings, and it was hard, and it's all of a sudden gotten way better. If you paid attention to Google Translate, you would have noticed in the last year and a half the same leap made it really good. It was a great article in the New York Times on that. So you can't see the example there. This says, it says, well, how do you feel about smoke? Can you tell me how you feel about smoking? Relieves my stress, and the thing responds, I understand. It relieves your stress, and then, which isn't very brilliant, and it says it makes me happy, and it says I understand it makes you feel good. So that's sort of correct interpretation, but we're early days yet, so here's an example of how bad it is. What's bad about smoking? It says it makes me cough. So smoking is pleasant and relaxing for you. No, that's not correct. What else is bad about smoking? I hate it. I apologize, I don't get what you're saying. People run away from me when I smoke. Sorry, I don't get it. So we actually haven't trained our machine yet. So this is an example of how it's not working, but that's because we haven't trained it yet. So it's just the bare bones of the conversation. There was a question that asked that I wanted to address, which is this possible without AI? I think some of it is. I think there's obvious inferences from location, for example, as I said, with respect to social anxiety. But I think we were staring at the sources of data that we have, and it's more than I even described the other day. We really could see that there may well be patterns about location and the words that are being said, and the light and the motion of the phone that a smart machine learning engine could suss out that we couldn't suss out. I'm hopeful that's true. And as I said, this work with natural language processing is a real breakthrough that enables perhaps really worthwhile chatbots way beyond what we're talking about that could help people with mental health issues by talking to them and understanding what they say. So I think those things are super possible. I have two last slides. They were asking me, I should say, this is all new to me, although on the weekend I learned that I do have a course assignment next fall. I'm going to be teaching an introductory machine intelligence course. So now this question about how easy or difficult is it to get started is one that's I really have to get my head around. I don't know if we should leave this till later, but I had a couple comments on what does it take to get started. From my perspective, there are 5 things that kind of you have to get a sense of. One is about the data. The source of data that you're going to train something on is crucial, and even understanding what data is. Stock market data is pretty obvious, but not everybody knows what sound turns into. What is that data? How do you look at it? How big is it? And how do you design something that talks to it? So I think there's some fundamentals from my own world of signal processing that sort of has to, a little bit you have to learn there. I think the biggest thing you have to learn to be operative in this world is software. like all of these machines fit within the context of much bigger software that connects you to the internet and processes the data and makes decisions based on the data, connecting to these machines. And so you have to be literate in software, I think, somehow, or you got to pay somebody who's literate in software. And then there's the theory, which you have to have some sense of what's going on. Of course, we all have some guess at what our brains are doing and what these things are doing. To become functional, you have to practice it. And so that means you have to start with something that makes sense to you and build it and watch it learn. And then I think, as Charu said, you need something that can do the heavy lifting of computation. That's kind of different chunk of this to know how to have a big enough computer to solve these things. And I'll just end by saying, they were asking about resources, and you can look online. There's lots of suggestions online. The only unique thing I have is this podcast, actually. I'm quite fond of it. It's called Machine Learning Guide by this fellow named Tyler Rennell. He gives a wonderful forest, not trees, view of the field. A little bit tuned for computer folks, but also he does it in a very accessible way. And so I highly recommend it. It's just come out of the last half year or so. So, and the rest of these are just standard books that everyone, other than, of course, jumping to Google's tutorials on the TensorFlow. If you want to jump in, that's where you go. TensorFlow.org and tutorials. And
Thank you all so much for your opening remarks. Let me just move this out of the way, and we will get to some questions. Myself, it's you.
Just a point of how this is going to take place. Initially, the guys wanted to do a moderated discussion, but they have some key questions they want to place to the panelists. So that will take place over the next 10, 15 minutes or so. But then you'll notice we're passing out a series of questionnaires. If you have questions for the panel, can we encourage you to write those questions, one or more, on a piece of paper, and then we will be in a moderated discussion. So you and Jesse will be passing those questions on to the panelists.
So one major thing I want to start off with is to understand when machine learning and AI techniques are more useful than traditional statistical analysis. So maybe, Charu, you could start us off on when we should be using machine learning over statistics.
Right. So in practice, I think one of the really great advantages of using machine learning or deep learning, which is a more neural network approach, is you don't need domain expertise to do these things. So for example, let's say you're a quant at a hedge fund. Back in the day, you'd maybe use some of your domain expertise to understand, how to read a financial statement, how does that data, what does the data that you're looking at mean? Or let's say you're at a bank and you're trying to figure out what the likelihood of someone would be to default on their loan. You probably use some domain expertise to figure out, in your large data set, what features in that data are probably most important. The nice thing, though, about deep learning, which is what I do, is I don't actually need that domain expertise. I basically let the math that I'm crunching, figure out what data is most important. The downside of that, though, is, and we experience it in kind of a business context, is a lot of CEOs or business development folks will push back and say, well, I don't understand. This kind of seems like a black box, and I can no longer say that, it's someone's income that is most telling of whether someone will default on their loan. And so I think the nice thing about deep learning or machine learning is, again, you take out the expertise, and that makes it possible to work across different verticals or industries. So I've worked in renewable energy, but I don't have an energy background. Currently, I'm working on financial projects. I don't have a finance background, but I'm still capable of doing those things because the way the models work is I don't have to necessarily understand everything about that data. Now, I think it's still useful to understand what the data is saying from a business context and figuring out, what is most important to your clients and what is most important in terms of the product you're developing. But I think the nice thing about AI is it's so broadly applicable, and I don't need to look at a table and figure out, these columns in my table are most useful, so I'm going to pull out that information. So that's kind of why we use deep learning integrated.
Would any of the others like to answer the same question?
Sure, yeah. So one of the things that, at least I feel within the astronomy community, we don't see machine learning and AI in general as an alternative to traditional statistics. We see it as an evolution on them, right? I think one of the challenges in astronomy in general is we're trying to describe phenomena that have so many different cause and effect relationships, so many different physics that's involved, so many different processes, that we can take all the help we can get and then use that as an indicator to figure out what should we be focusing on. So yes, we want to be able to classify. We want to be able to say that this process is probably the more important one for us to take a look at. So let's try to model that. And so machine learning and AI techniques can help sort that out and help act as diagnostic for us to then go back and say, okay, now can we try to figure out what the causation is here, or what the chain of reactions are here.
Yeah, so yeah, I totally agree that I would place machine learning, I would consider it to be a statistical technique. Just, the way that when I teach that, which is an introductory course for social scientists for graduate students, I like to use logistic regression, which is probably the most common model in political science, and show that in fact it's also a machine learning classifier and one of the most basic ones. And that therefore, we're really talking about sophisticated statistical methods and I see them useful mostly when you have complicated data. That is, textual data is a good example, where you would go with what we tend to call machine learning. There's just statistical models that are a bit more flexible process that kind of data.
Like the galaxy visual data Mufti was talking about.
Yeah. It's, there's just a lot going on there. So there are different ways that traditional classifying, traditional statistical ways that we learned back in high school. How do you try to fit lines to these things? And it works at some level, but when the model gets more and more complex, you need to find ways to try to get the deeper implications with it.
Any thoughts?
Yeah, I was just thinking, the way Chara answered the question, she interpreted it in a way that is interesting, that you talked about domain-specific knowledge, and the reason that relates to the question on statistical methods is when you're applying statistical methods, you know a lot about the underlying thing. That's the domain specificity. So I think that's a really important question that I've argued with colleagues a bunch. I have one particular colleague who swore off all machine learning up until recently, saying he knew in his specific domain, he was a specialist in methods to do eye tracking, figure out where your eyes are looking. And he figured he knew how to look at those images and come up with specific statistical methods to make this tricky determination. But recently we've just decided we're going to throw it at a convolutional neural network just to see if it can do a sub-piece of the problem. So both of us kind of felt that way, right? That our domain-specific knowledge would always beat these machines, except changed our minds recently.
I think that's a scary part for some people. Acknowledging that maybe you don't necessarily need the expertise, or maybe a computer can do it in a different way. And so I think sometimes people will push back to that, and I think maybe there's like a meeting area, maybe there's somewhere in the middle that works. But certainly in my experience, you can get things to work and not necessarily know why it's working.
Well, I think that's what the next stage really leads to, which is rather than trying to use your domain-specific knowledge to try to come up with an algorithm or come up with a process to make it work, using these techniques to try to develop domain-specific knowledge.
Yeah.
Right? And I think that's where it really can be interesting. And say something more fundamental about the data set or the problem you're trying to deal with.
And it also removes, you were mentioning earlier, the effects of bias, for example. And so, again, it's an objective way in many ways to look at data, and so it's super useful when you think about how do I remove bias from my decision making.
So thank you all for addressing that first topic. I think we all heard data mentioned over and over again. So clearly there's a huge importance of having a good data set. So let's talk about that. How much data is necessary? How much is enough? Clearly, on the scale of millions and billions of data points, using machine learning or AI is a very helpful technique. But can it be applied to smaller data sets? Can we? How do we use it in fields where we don't have millions of telescope images or hours and hours of speeches to analyze? As well, what type of data is it good for? We've heard a bit about natural language processing, so text, as well as image, but what else can we study? So, whoever wants to start.
Well, I mean, I've always been, I've been lucky. I've been in a fairly data-rich environment, right? For the past, 2,000 years, we've had more observations of the night sky than we know what to do with and how to process. So we haven't actually had to deal with the problem of too little data yet. But I think it actually pairs well with the idea of how does this relate to traditional statistical techniques. That's where you can, when you have a small data set, that's when you can understand what is actually occurring with the traditional statistical technique. You can say something about the distribution of given properties. You can say something about how well you know a certain parameter in this entire population. Where, I guess turning the question around, I'd say where machine learning really shines and where AI techniques really shine are where you can't easily do that with the traditional statistical technique, where there's just too much heterogeneity of the data in there that you can't try. It's just a fool's errand to try to piece out any individual process or any individual subset by hand. I think that's really maybe an interesting way of looking at where to start using AI.
Okay, I can jump in. Sometimes you do encounter, in terms of having enough data, there are times where we've encountered, if you have, let's say, different classes of data, or let's say you're trying to categorize people, and certain groupings will have a very small representation, but there are things you can do to kind of augment that group, which is an interesting area of research. But I would say, similar to what you mentioned, often our problem is we have a lot of data and maybe sometimes the quality of the data isn't great. So a lot of our work entails cleaning that data or getting it into a usable format. That's kind of a bigger area for us, at least in industry. When you're in academia, you probably maybe have access to more clean data sets. But when you're working with real world data, it's super messy. So a lot of issues can arise with using real world data. And so that's a whole other area of getting those pieces of data into a usable way and figuring out what's useful and what you should toss.
A specific example?
Yeah, I think natural language is a great example of this. We were working with kind of transcripts of phone calls, for example, and people speak in, everyone speaks in a different way, everyone has a different way of speaking. Sometimes when things are translated, there are spelling errors, things like that. And so a lot of work has gone into how do you automate cleaning data? That's a big area. And then even just, even with financial data, sometimes it's super messy. And so, again, that's a huge area and a huge chunk of my time as well as figuring out how to make them useful.
Is it always true that more data is better?
You can have lots of training data. So the concept you're training and predicting, so it's good, especially in terms of supervised learning, although it's not always necessary to be training data. But if you're doing supervised learning, you start with examples, for instance, and did by humans, the more you have, the better it is, the more confident you'll be in your prediction. But the thing, I think the great thing, so the original question is about whether there's enough data, how much data is necessary. The great thing I think is that so many people sharing their resources right now that it's hard to find an example where there hasn't been somebody who's like sharing a large corpus that they have annotated by. You have resources like people you can hire online. That's would be a good ethical question. But these people that you can hire on crowdsourcing platforms, are they really not much, but they code data for you. They tell here are examples, and then you use that to create. Well, I guess you could have that with planets, or you can have that for all sorts for textual data. So it's easy, I think, to get data. It becomes more easier and easier, and yeah. We are blessed with data right now, so many things that people might be interested in working.
I will add one thing. There is an edition of the Times that I think came out maybe last year, and on the cover it said, "Data is the new oil." And so I think what we're going to start seeing is a lot of companies, a lot of these entities that have a lot of data and own a lot of data are going to be in a really powerful position. And so even if there is a lot of ubiquitous data, I think that the companies and the organizations that have that data are in a really good position. And I hope that many of them will share that data. But I think that's a whole other issue.
Okay, let's move on. Starting with Jonathan this time, what are some of the commonalities between problems that make them suitable for machine learning approaches? What are the characteristics of a problem that we should tackle today?
Good question. Yeah, it's not my home turf, but I think that it's a little bit related to your previous question on using regular statistics. It's maybe in the places where that breaks down. There's many dimensions, so many dimensions that the human mind just can't keep them all together. And the computer mind has no problem with lots of numbers, as long as the learning processes are still succeeding. We appear to be succeeding. So many dimensions of data, which classic canonical success that brought us here was in computer vision, having the ability to to look at something and say what's there, to recognize and to detect an object, a face, a chair, and to recognize, to say it's that person. And that all of a sudden got a lot better in the last 5 years. And that's an example of something. There's huge amounts of dimensions. Obviously, third dimension. Yeah, but all the different things that can be in the picture. I think that's an example. And by the way, I happened to bring, just because of this, on that, I brought on a phone released from Google an app that just looks at stuff and tells you what it is. And so you watch it, it's operating in real time, it tells you the top 2 things that it thinks it's looking at. It was really good at picking up the radiator in my office. It's like a radiator with 1.00 confidence.
Is that available to everyone?
Yeah, I could show an Android phone. It's kind of fun to look at. I'll show it afterwards if you want to see it. I'll show it to you. So I don't know if that addresses your question. That is the canonical example, and that was the thing that computers were terrible at until these last little while. And it's a really multi-dimensional data set.
Can you pinpoint the advance that led us to cracking this problem? Is it just that computers are faster, or was there something more to it?
I'm going to echo what Taro said, and I can directly quote the definition, because he said to me, he said, I didn't really do anything. It's true. So the computers just got a lot faster. Yeah. Particularly the GPUs and their massive performances has really enabled the networks to have millions and millions of variables that are being optimized, and throwing lots of data and getting through that enough speed. And they added a bunch of cleverness on how to make it efficient. The ideas were all there, so that efficiency and the computational power. What do you think?
I think there's actually one other aspect to it that we often miss, which is, a convolutional neural network, the kind of stuff that is doing computer vision now, is different from a neural network, right? So there has been a difference in the way that we approach the problem. And so traditionally, a lot of what a neural network was supposed to be was mimicking how neurons in your brain work. And so that actually ended up being a bit of an academic hiccup, right? Because you can build systems that look like that. There are systems that classify how far things are using that process. But it ends up meaning that if you want to do it exactly the way the brain does it, you need a lot more layers and nodes to be able to do the same problem than what we're doing now, which is you've actually altered that algorithm. You don't necessarily need everything to combine in a linear way. That's really the big advance that's happened in the past 5 to 10 years, is we've got over the hump to think that the way the brain works is exactly the way that computers should be doing it. Computers should be doing something in a slightly different way that makes the problem a little less complex.
I would agree that convolutional neural nets are an important leap. Although I think I would actually guess it's the other way around. What the convolutional neural net brought was that if there's a chair there in my field of view, it could just as well be a chair there, and so I don't need to double that. I can reuse that. And I'm pretty sure my brain does the same thing, that it uses that same observation, and the convolutional neural net was a way to get there.
It's certain, but your brain does it with like millions and billions of neurons, whereas many of the layers that we program don't need that level of complexity.
Ludovic or Troy, do you want to address the commonalities between problems?
Sure. Well, I can use this, quote somebody else. It's a good thing to do to sound eloquent. But no, from the very good book on deep learning, Phil Ventio, and I recommend for those interested in learning the advanced parts of this topic, especially neural networks. I think they put it very nicely. They're saying in the past we used to think that computers as being able to do tasks that are very complicated, like very difficult calculations that humans couldn't be doing. But right now, it seems that we want computers to be able to do simple, intuitive tasks that we know as humans how to do, like recognizing a chair, but we cannot really explain how we do it. And that's seem to be the commonality of many AI projects that we're moving toward these models being able to replicate what humans do intuitively, not necessarily just complex calculations.
I guess I'll ask one more question before we take some questions from the floor. Just wondering, how accessible are these techniques to non-computer scientists? So Jonathan, you mentioned you do have to know how to know some computer stuff. We talked a lot about GPUs, so is that something you can just buy at the store, or do we have to access the cloud or something like that? So if you can talk a bit more about
I bought the GPU yesterday.
Oh.
$3,400 US.
How did you find one? I find that all the crypto miners are
Yeah, the crypto miners got the low end stuff, and all the ML people are stealing it. There was an email that came out yesterday from NVIDIA that said their high-end Titan V is available, and my grad student sent it to me and said, we have the machine and we needed to put it in. So I bought it within an hour of that email coming out, because yes, they're very hard to get. $3,400 is a lot to pay for a machine, but it's about 3 to 4 times the performance of anything else next to it. So to the other point, I'm thinking a lot because I have to teach a course in this for 2 engineers who, well, what you need to know, and actually this morning really kind of realized that the way I'm interested in other fields is the way it's being taught currently in computer science and in electrical and computer engineering. It's super heavy on the math. Like massive amounts of math talking about the theories. I actually think that's really wrong, and the wrong way to start. It actually is. I'm going to be able to teach just the basics of it. Here's the essence of the linear regression, logistic regression, which isn't that complicated. And it kind of grows from there, and then here's a machine that you can try. You should jump in and try. And I think that in my department actually there's two kinds of people. And there are 8 people in the department. There's the Dems that like the math and then that like the real stuff. I'm definitely on the right hand side of that. And I think in this case, it is a machine that's now in a state where you can use this. So practicing to use it and not getting a little caught up in all of the different proofs or semi-proofs. We don't even have that. It's better to get out there and use it and work with it and jump into it. And so I would go to my bottom link slide. You can go to statistical.org and walk through their tutorial if you've got a little bit of software capability and experiment. I think that's the place to start, and then fill in the holes and say this is why we think it's working. Chime in or
Yeah, so I think it's an interesting time. I think a lot of companies are working to make tools and packages that are accessible to people who aren't necessarily trained in machine learning. So for example, Microsoft has a product called Azure, and it lets you basically upload your data to their cloud, perform a series of transformations or computation on it. And so I think we're going to see, my prediction is we're going to see kind of machine learning, deep learning become more of a commodity or more of like a general software skill set, or they're going to be products on the market that enable you to do at least the low-hanging fruit. But I think, and just jumping on to what Jonathan was saying earlier, my graduate degree was very math heavy, but now that I'm in industry, I don't touch all of that math anymore. It is, there are so many tools and packages that you can use to get things that actually work in a quick amount of time. So I think it is becoming more accessible.
Well, we're going to transition now over to the questions from the floor. But while they're doing that, because I'm having a moment to read through them and organize them, I'll use my chair's prerogative to ask a question that's entirely selfish, but comes back to this issue of a lot of what we're talking about are the ways, it seems, the ways in which we can use this in order to take metrics, recognition patterns, diagnosis of parameters that we know and massively increase the ability to do that. But you referred as well, in particular, Mukti, to this idea of changing that domain knowledge to actually get to the point where, in fact, this can do more for us. It can help us refine and perhaps even dramatically change how we look. And so now here's my specific and selfish example. I am chairing the National Academy's committee for the search for life in the universe. And so we find ourselves debating, what's the signature of life in the exoplanets? And what is it? So how is it then, in this context of changing from the idea of recognizing that which we know to searching for that which we don't know, that this might be able to help us? And would you care to speak to that while these guys are organizing the questions from the floor?
Sure. I think there's a lot of value in a lot of these techniques in telling you that you don't know something, right? A lot of the techniques, specifically a lot of the natural machine learning techniques, not necessarily convolutional nets, can tell you how similar things are. So that inherently tells you how some similar things not. And that's where I think a lot of the power becomes, where you're not saying something that you've classified already. You're just saying, here's my data, here it is, all the information I have. Tell me what things go together. Which one of these things is not like the others, to quote a program that I love we did. And that's where I think a lot of the power is going to be. How well can we start to find these outliers?
All right, I think we have our quote of the day. The principles of Sesame Street will help me find life on exoplanets. I'll pass it back to you guys then for the moderated floor discussion.
Okay, so our first question is from Elisa Strong from CFAR, so specifically for Ludovic. But if anybody else wants to chime in. So do you have any concerns about diversity of your data? So not everybody expresses their opinion online. So how do you account for missing perspectives?
It's an interesting question. So I view that as a question of whether our sample is representative, which is a long debated issue in the social sciences and I guess elsewhere. Yeah, that's a very good question. I'm just starting to do studies. I'll probably have lots more to say when I finish the project that I'm currently doing on. I would say, compared to the techniques we've used in the past, I don't know if the problem is better or worse. In the past, it was very difficult, for instance, in surveys to reach people who have higher income. You always, there's it's interesting to because statistical theory is always based on the idea of a random sampling. You're supposed to have a random sample of the population, which is virtually never ever the case in the social sciences. It's even in experiments. So most experiments, that's the case in health sciences, are based on undergraduate students who take medication and been tested are not haven't been tested on a representative sample of the population. So yeah, there's a bit of that. But my sense is that actually it's better that we reach more people than before. That's the question of age group. So you had some probably the demographics of people using social media in particular we know are to be different. So there's a number of statistical techniques after you've collected data that you can use to try to correct for that. That's a very good question. That's something we need to think about.
Well, I have a question from Helen that relates to something Jarvis said about data is the new oil, but this is addressed to Jonathan around competition. So given that AI development requires a lot of data, how can Canadian researchers compete with, say, China, who has a much larger potential data set and less strict privacy issues? It is addressed to you.
Well, we don't have to deal with the size of our country given public data sets. There's lots of data sets that span the world. So I guess it's really what I think there's fairly large movements to open up data sets. It's important for advancing all fields. So I haven't heard that I haven't felt that we've been disadvantaged here for the small population of our country. I think maybe I would reflect back that the worries of corporations who well know that it's oil are keeping their data secret, and they have the big accounts. So I would say I reflect it back as an issue of profit motive versus the social good motive countries. And so countries should be trying to do things good, and companies are trying to make money, so they keep it secret. That, I think, is a question of policy, but whether at some point data should be like patents. You get to keep your data for 10 years, maybe, and then you have to make a budget. So maybe we should have legislation around that. Now I'm talking to I have no expertise in it, but maybe that's the bigger question.
So I guess this one is more of a general question for the entire panel from Abhishek. What are some of the barriers that you face in adopting AI in your field of work? Are there any?
I think I can speak to my field at the very least. I think one of the big concerns that we have, and astronomers in general have with it, is that it is currently a flashy buzzword. Right? Everyone talks about it, and so there are going to be the first couple papers that come out that basically produce nothing that actually stands up to the test of time. And so a lot of people will not necessarily want to, they won't want to invest in something until they know they can provide them with a result or something that is going to be productive for them. And so I think a large part of the barrier is being those early adopters and having those early adopters to show that, hey, this is science that we could not have done without these techniques.
I'd say in a business context, one thing that we're grappling with is the issue of explainability. And so with traditional methods, and I kind of alluded to this before, we could find that certain feature or variable is maybe related to the thing that we're trying to explore. But machine learning or deep learning in many ways is a black box, and it's hard to get people to trust a black box. And so I think the issue that we're going to face is it has to do a lot with trust and security as well, because we might create a model that works well, but how do you get the person on the other end to believe that what we're doing is reliable and robust if they can't really put it in terms that they can understand? That's something that we're dealing with in the business landscape.
Just wanted to echo that same, that's true in spades when it comes to medicine. Who's going to take a decision from the big black box without an explanation? I think that's my colleague Brendan Frey, who works in this area and has a company in this area, said and he had a partial solution to it. Was in the work that he has a company called Deep Genomics, which is trying to interpret, use the genome in order to create drugs that work. And he doesn't have a big black box, he explained. It's not genome in, here's a drug out. He says, together with his colleagues, this goes to the domain specific knowledge question. They know these various processes, and they can get data at the input and output of these various processes that go on inside the biological systems. So the decomposition into those sub-machines provides some knowledge about what's going on, rather than one big black box. So key thing that maybe is important to look for, maybe in business as well, is to break it into pieces and say, well, this part, like the cellular translation part, we know this from that, and so there's a little more knowledge and a little less context.
Did you want to add anything?
I think there are barriers in the social sciences that are probably more pronounced in STEM disciplines, in the sense that it's still new. I think it's almost inevitable that the statistical techniques are so fascinating and helpful that I think it's inevitable that in social science we will use them more and more, that in 10 years it will have become mainstream. They're that nature, so really not my discipline. The problem for that, if you're a researcher, it's more of a practical issue, is that say you want to publish your research, it's a social, academia is a social thing, very social thing. Surprisingly, we expect that there's a hidden room with lots of scientists who know everything, who are able to review the papers and accept it, but in political science at least, or even in economics and other social sciences, there aren't so many experts. So it's you may face resistance. So the most annoying thing is when somebody who doesn't understand the methods and criticize them, that you can enter in a discussion is not really agreeable. So you have to go through that. But it's so I think it's rewarding working on something that is new and things that haven't been tried is compensates for these difficulties. But there are definitely these sorts of difficulties in my discipline.
Maybe Mubdi or Ludovic could address this one from Dr. Carolyn Silpen. Why has AI image analysis progressed so much further than natural language analysis? What are the main hurdles in natural language processing?
It has improved a lot. It improved so fast that it's difficult to keep track of it. I mean, the scientists are fascinating. They produce, there's a state-of-the-art thing produced, and literally a few months later, somebody is even made something even more powerful. So I think there's a lot of interest in natural language processing, and even applications like Alexa and so on. Quite convincing in terms of what can be done. I think in the social sciences, that's really the part. I think analyzing language is so important and fundamental for our disciplines that it's surprising that it's not. I don't think the question was given to why isn't there more interest for natural language processing in these disciplines? Then I would agree. There's a gap to fill there, and I think there should be more interest.
I think adding to that also, one of the things that I would say is that image processing, or images inherently, are very rich in the information they contain. And so that makes it a little bit of an easier mold to hit. A good example of this, I mean, if you want to talk about in terms of information theory, one could say that the entropy in an image is so much greater than what you get from just potentially a couple words put together. To the point where there are groups that are working on, for instance, being able to reproduce exactly what an image looks like to very, very close margin by removing all of the 1/8 of the pixels randomly, and you can reproduce that image because we know, for instance, if you have a pixel that's right here, what's the probability of a pixel next to it being bright as well? And so the amount of information that's in there, just based on the context, is very high. And so it makes this an easier task to do.
It's such an interesting question. We could talk all day about that. But more to the point of the original question that I don't think I addressed properly at first. What an example of hurdle, I think, is that I'll use the example of sarcasm that people always point, well, you have a machine learning model, how do you, or a model of natural language processing, how do you account for sarcasm? How can you detect that? And it's something that depends on context. So you were thinking about that, and yeah, as humans, we rely on context. So I know that person says, oh, of course, I love Donald Trump, but that person is sarcastic. They don't like it because you have a prior experience. But if you're just looking at the statement, it's very difficult to deduce from that. Humans also have difficulties understanding sarcasm. And if you're a lecturer and you use sarcasm, be careful. There will always be somebody in the room who won't get to the sarcasm, and you get trouble. So these are the things that in language are very difficult, that even for humans are not consensual, that may make it more difficult than an image. There's a layer of difficulty of latency that we need to capture that's difficult to grasp.
I guess just one last little point to that. The prevalence of the smartphone. I think that's done a whole lot to it. There are just so many images that people have uploaded, classified themselves based on their caption or whatever, that this is such a rich data set that people have the ability to play with. When did Facebook start creepily telling me that my mom's in a given picture versus my sister's in a different given picture? That's years ago at this point.
So I think this next question, we actually have quite a few people asking this. And it's something we'll touch upon more in our second panel, but maybe we can ask panelists here what you think about the regulatory ethical framework that you might need with the expanded use of AI. So questions about ethics.
I think Jonathan had to deal with this already, as you were mentioning.
My projects nowadays all need ethics for what they're dealing with people, and the ethics behind recording ambient audio that our subjects can give consent for. But and in Ontario, they are legally allowed to record anybody around them, but I don't think it's a gray area whether we're allowed to then get a hold of this. So that's kind of legal issue. I think the thing that took into my mind from that question, though, was there's enormous questions around what an insurance company can do to you based on your genome. And I think that now needs to be, that's been around for a long time. Movie Gattaca talks about that all the time in a big way. I think the same question now arises from data. There's enormous things that people can learn about us from our data more than we know about ourselves. And so maybe you need regulation around that. If you have rights to be considered part of the regular population, even if you have a particular gene, your health insurance expensive. Maybe there's other things in front I work on, mental health. They talk about, they call it digital phenotyping. It's essentially the same thing as the genome. Like, what are these elements of you that we can pull out of your digital behavior? We probably are going to need protections around what insurance company can based on that. So that's just that question. I'm sure that question's going to show up.
Even second panel? Would anyone else like to?
Yeah, I would say in a business context, I think we will eventually maybe need the government to set some policies. But from what I see, the onus currently is for individual businesses to decide how they proceed and how they handle data. So I can give you an example. At Integrate, we've made the conscious decision that we will never, identify people on an individual basis. So we never use something called personally identifiable information, PII. So that's something that we've decided is important for the way we practice business. In one sense, it sets us at a disadvantage because we don't track or target customers directly, but we think going forward, it'll set us in a good position and people will become more vigilant about their personal information and data that they're transmitting to the companies, whether it's Facebook or Google, what have you. And so I think what I predict what we'll see is certain companies will kind of set the standard or the bar, and then other companies will kind of have to coalesce around that. That is if the government doesn't step up. But I would say in many industries, for example, banking, there are tight regulatory restrictions on how you can use data. For example, in some of the work that I've been doing, I don't actually get to see the data. We do something called masking the data. So you can't see it, but you can see maybe the shape or the type of information it is, whether it's a number or a word or something like that. So there are some technical things you can do, but I think also each industry regulations.
I think one of the things that needs to be said is that we're still very much in the Wild West days of AI and how we're dealing with it, how we're coming up with just the regulatory frameworks, but more importantly, the literacy, right? It wasn't that long ago that people didn't even think twice about setting location settings on or worrying about their phone tracking, their GPS location, right? We now know that that can be used, and certainly one of the things that was very clear coming the Arab Spring was the use of location services on cell phones to try to attract individual protesters. That brought it to the forefront and made us more literate about what can be done with this. We're still not in the day where the general population, I feel, has literacy, or we ourselves even have a sense of what can be done with the data. So I think that's really going to be a part of the push.
I have another question that'll segue nicely into our next panel. Maybe Charu could start. You were mentioning previously about the black box and how you don't need specific domain expertise. The question asks, to what extent can we improve the transparency of deep learning methods? Is there some fundamental barrier from it being interpretable to humans?
There's a lot of research in this area, and I would say from a technical standpoint, for example, in computer vision, there has been some work in understanding how the various layers in your network, what are they picking up on, what are they learning in particular. This isn't my area of expertise per se, but I would say this is an active area of research. Jackington also has a lot of work in this as well.
I agree. It's actually possible. The most convincing papers about deep learning, they explain they know what the layers are doing, and yeah, especially in the academy, we value a lot that the scholar is able to understand what's happening. In some applications where it's more, being very pragmatic, and sometimes you see computer scientists are a bit more like that. I would say that if it works, if it's accurate, then it's good. So passes the test. But certainly in social sciences, in most sciences, we want people to be able to understand. So there's a bit of that. I think the methods will improve. Right now we still have we have these libraries that are very recent that make it much easier to do deep learning. I think the next step will be they will be even more sophisticated and be having more tools to be able to identify what are the coefficients, examine what are the relationships you're fitting, and this will help to make it more understandable to people using them.
I asked a colleague of mine in computer science who's machine learning, who's the director at Institute, Rich Semmel, that question one day, and he said, super important question, lots of research on it. He said one way they try to answer that question is for any given machine, they would hunt for examples that are really close together that give two different answers, and that's a partial exploration. So somehow that describes the boundary of what Silicon Valley fans, hot dog, no hot dog. You know what I'm talking about. So what picture is on the example is on the boundary of that. So one way to create transparency.
And I guess we have plenty of questions, but at this point, I think if the audience wants to also jump in with comments, raise your hand. Enrich the discussion. Somebody asked, as the world continues to deal with issues of fake news, do you think AI can help with that and verify images and examples? So I guess, I don't know if everybody's seen this, but there was recently a video where Barack Obama was, fake video of Barack Obama speaking, and it looked very real. So that's something that can pass off as real news.
Super interesting question. Makes my field. Everybody seems interested in that question. Yeah, there's a lot of efforts there right now to detect that. I think it's complicated. First, you have to establish the true value of the consumer reference, but that's how the other components of AI knowledge base or ontology, where you can verify, but also it has to be updated. You need to be able to. One of the most shared fake news during the last presidential campaign in the U.S. was the news that the Pope had endorsed Donald Trump, which should be easy to verify. I think this leaves ones because I think automatically we should be able to detect that. And some of them would be more difficult. It's not a possibility to easily verify whether a claim is true. But yeah, there's smear campaigns that are this is a huge problem in politics that well, we probably heard people in Britain say they've been targeted online because they took a stance against the foreign regime, and so if the internet is used to attack them and prevent them from speaking, that becomes concerned. I think AI, machine learning, if that's that if we can use that to understand the problem, at least identify and alert us, some humans, to look at these, then that's a super important part of the agenda right now.
I was under the impression that Facebook was already actively trying to do this, where based on the reliability of the source itself, when somebody posts a link, they'll actually have a little like warning saying that this link is from a potentially unreliable source or something like that. So I think there are attempts at doing this, partially because of the prevalence of it in the past U.S. presidential election.
Just a quick comment. So I think implicit in what you all said is the assumption that the motivation of whether it's the private sector organization that's looking to innovate or the scientific exploration operation or machine learning process or the analytical context or text is a positive motivation. It's to learn, it's to understand better, it's to share our knowledge. So, but sadly, in the world which we share with others, there are some folks who look at these kinds of data-rich propositions and their motivation isn't quite as constructive, positive. So you think about, take a government, not necessarily ours, but there's all these data sets that was referenced to by Professor Rose. And we assume that we have rules and laws in Canada about privacy and all that good stuff. Well, there may be governments in the world for whom they don't have those rules and they don't have those protections, and there's no due process or rule of law. And as these networks link up for a whole bunch of reasons, medical reasons, risk analysis, textual analysis, a lot of what we have here will end up in other places who may not actually have the same frame of reference that we do. What's your advice about what people who care about the value of AI, its importance as an instrument for progress, economic and social? But where do you go with this when the risk is so large and in another way is so diffuse? What's the way that, based on your own understanding of it, which is pretty substantive, where would you go with this? If a distinguished civil liberties lawyer sat any one of them down and said, "Here's my problem. What's your advice?" Where would you go? What would be the first initiative that might come to mind?
That's yeah. I mean, I think just going back to the idea of literacy, I think that's the first step, is letting people know that this is happening. And you're right, this is happening, right? Information is being collected from the Snowden leaks. We learned about the databases of information that have been collected by foreign nationals by the United States. I'm probably tracked, having lived in the United States for the past 5 years as a non-citizen, right? Like these things are being collected. So just the knowledge that it's more than just benign. I think that's something that needs to be within common knowledge. I think that's a zero order place to start.
I think the question, did you want to say
Go
something?
ahead.
So I like the question a lot because it's very political. I think there are policies that can be put in place that would help a lot. So I think the problem right now, especially with data on the internet, is let's start with building up data there. I don't think individuals are protected. It's very difficult to protect people against libel online. What do you do if there's so many cases of teenagers who commit suicide online? And the Europeans are a bit more ahead of us in terms of protecting the right to not sure to phrase it, but now you can ask for certain things to be removed about yourself. I think we need to think there's the balance between freedom of speech, access to information for scientific purposes, and then protection of the individual rights. And I think right now the individual is losing the battle. It seems to be much more of a subjective opinion. I'm not saying I have the truth on that, but my sense is that, especially for future generations, your entire life could be potentially accessible and if we don't have control over our reputation, to me that's a major issue. I've observed it a lot just by studying stories of politicians who've been attacked online, their reputations have been broken. And so what do you do if you don't have control over your own life because it's taken over by others? I think it's just a matter of updating thinking, making our policies more modern and taking that into account. And I think Europeans are that we've already made a lot of progress. It's something we need to think about in Canada. So just more of opinions, but I guess the question called for it. I don't know if the other.
Yeah, I would say this also ties to the previous question. There's a lot of the research that led to whether it's video generation or creating a snippet of sound that sounds like Obama's voice. Is super innovative, and my belief is a lot of the researchers in this area hold themselves to a high degree of ethics and standards, and so I'm confident that the research community will proceed in a responsible way. And I don't think, for example, the solution would be to put a moratorium on the types of research that can be conducted or the types of applications, because I think things will proceed and merge on. But I think that's the role that the government plays in this area of setting the standards and setting the policies. I don't know though if Canada can enforce a regulation that would be upheld in another country. That I don't know if that's possible, but I think this is super interesting area of research. Question that's super important.
Related to that, the question evokes authoritarian regime. That's what jumped into my head when we were talking about. Has all this data that can now track its citizens ever more friendly, and even if they wanted to hide things, they can hide things, and the authorities in that case are not good at it. So you frighten me with this question. I don't know the solution, but that's just a slightly different interpretation of the others. That is very much a danger that in this highly connected society that we rely on our digital devices, we can't avoid except to run to the pits. I guess we'd have to rely on the rest of the planet to move in an arc that bends towards some kind of justice for those folks.
have time for a few more thoughts.
This is a question more on the commercial potential, or kind of where the future business opportunities in this space lie, and how much room for innovation is there left in the technology?
Oh, I would say there's a lot of room. I think a lot of companies right now are maybe only touching upon the low-hanging fruit, but I think there is so much potential. There's a diversity of industries that I would say are still maybe using a lot of old techniques or are ripe for disruption. I hate that word, but I think it's a great word nonetheless. And I think a lot of companies, large corporations are starting to want to use these technologies. And so I think there's a lot of room still for innovation.
I have an example that jumps to mind. I was just thinking, I was putting colleagues, a colleague in computer science, Sonia Fiddler, gave a talk the other day, and she showed enormous creativity in creating a data set that I hadn't really thought about for the following purpose. Her goal is to automate, make it easy to have robots do what they need to do. She just wants to talk to some robot and it figures out how to do that, which means you have to take words and turn them into action. And so she created this really interesting data set with her students. She took 50 books that had been turned into movies and paid someone to annotate every section of the book that corresponded to a scene in the movie and used that as the learning. So the words became these actions. And so that's a vast amount of correspondence between words and actions. And the first thing she did with it that was worked reasonably well was to figure out what facial expressions were given rise to from certain words. And so she then produced a big machine that put words in, and then a digitally drawn face would take on those expressions. But that was just one thing you could do with that data set. And to me, that evoked the creativity of creating that data set evokes all kinds of other things that you might do with it. So I think we haven't scratched the surface of what's possible with ideas like that.
Yeah, actually, just to add to what you just said, because I had seen Sania speak in Montreal at the Deep Learning Summit there. So one of the other things that they're able to do with that data set is to predict what action will happen next based on the frame, because you already have the text annotated, or I guess you know what's going to happen from the text. So they stopped and then it was a hilarious demonstration because they asked us in the audience to predict what's going to happen, and we were, I guess, not that great at predicting what is going to happen next in the video, and they were able to do so using that exact same data set. So lots of potential just adding on to it.
Yeah, I wanted to ask what your favorite network is. Ask anybody, but not necessarily one that you may have worked with yourselves, but just in general, one that you may have heard of. What you think is really like the most fantastic thing and transformative thing that's happening.
In terms of toolkit,
or in terms of a kind of network.
Machine learning application.
Yeah, favorite application.
The generative stuff seems amazing. Where the geo, Josh showed this when he came through, the ability to train a neural network to generate, just kind of doing it backwards. Right? Normally they look at things and say something about it. Instead of that, they created a method. I won't describe the method. Great. He showed generate pictures of juncos, which is kind of bird. So it's trained, and it just after we got good at it, they just started producing these pictures of birds that were different and looked like juncos. And so another one that was cheeseburgers, so generating a lot of different cheeseburgers. And so to me, what I found exciting about that is it's a little closer to thinking. Not quite, like the input's sort of random in these things. It's like random data. The output for these specific things were juncos and cheeseburgers. That seems like a set of thoughts. Like if I had enough of those around, I could produce some thoughts. That's how I started. So it seems like the next thing.
So yeah, in the sense that it can kind of go off and somewhere where you didn't intend it to go.
of my favorites has been partially because of the mistakes and the ludicrousness that comes out of it, but the machine learned or deep learned generated recipes. So they've fed in all cookbooks that you have and tried to generate recipes of ingredients and steps. And one of the first problems they found with it is that everything includes salt. So one of the first recipes was 7 pounds of salt and like some lubricants amounts, small amounts of other things. And it's gotten better, and people are actually trying to make some of these recipes now and saying, hey, it kind of works, or this actually wasn't half bad, or here's an interesting flavor combination.
Like Chef Watson.
Exactly, yeah.
Can I follow up on that? I mean, what can we learn from it? How can they improve that process other than by trial and error? It's a naive question, but that's my question.
I mean, I'm not involved in the creation of said network, but I think part of how the evolution of it has occurred has been they see the output. They see that these things just don't make sense. No dish should require 7 pounds of salt, right? So what in the network or what in the training set makes it think that way, and how do you modify it such that it realizes that salt is added as a flavor enhancement. And, it's more of one of the base ingredients as opposed to something that's trying to give you flavor inherently.
But it sort of goes back to my question from earlier.
Sure.
That it's all dependent upon our inputted recognition.
Very much so. That's particular.
When and how is that different point where it actually is able to transform?
Well, I think there were a couple of things that we found through these recipes, interesting flavor combinations that no human normally would put together.
But is that something other than random?
Yes, because you can, in these cases, it was that these classified these ingredients as having this flavor profile, these ingredients having these flavor profiles, and there's some mix between the two. So maybe other things within those flavor profiles mix as well.
So answer to your old question in this one that I think is relevant. Most of what we've been talking about has been called supervised learning, where you have data and you know the answer, disease or whatever. You were earlier asking, is there some insights that can be created? Another thing called unsupervised learning, which I read about in Goodfellow's book, or Goodfellow's book. I have a vague sense of it. There are no labels. So you go, well, what do you feed into the machine? What happens? And apparently, if I understood this correctly, it comes down to compression. In that if you feed in this information and you try to get the thing that comes out of the network to be able to recreate what fed in, but with less information. And so if you can cut down the amount of information you need to regenerate the original input, it means you've figured out what's important. It's like principal component analysis, or that means anything to anyone. But it tells you the features without you having to teach what the features are. I think that's the answer to your old question. So
yeah, it's basically parenting.
Yeah, that's actually the example I was giving. Is, we don't label everything. Figure stuff out.
As another example, for instance, I'm coming from a completely different area. We try to do the arts and so really from the creative world. And just one example, there's a painter in Berlin who has painted 9 paintings and feeding them to the machine. The machine learns his technique and spits out other paintings which are different from his originals, which he's using then again to create different. So there are many examples in the arts.
Yeah, to add to that, Google has an interesting project called Magenta that is about how do we create music. For example, let's say you want to create something that is in the style of Bach or the style of Michael Jackson, or how do you get these networks to just create something spontaneously that sounds beautiful, but then what is beautiful? So a whole other sort of questions.
So, just the mention of supervised learning reminded me that long ago I had a supervisor called Christopher Longwood Higgins. He had 2 students, the other one was called Jeffrey Hinton. What we were discussing, because Christopher wanted us to, was whether you would ever learn anything with the aid of a computer. And Christopher Longwood Higgins said, never, forget it, don't waste your time. And I agreed with him and I followed his instructions. Jeffrey Hinton didn't. But, you know, there are many fascinating things you've said, but we are coming back to that question. You are asking, has something creative come out of the computer, and what would that look like? Certainly dangerous things have come out of the computer, and then I'll stop talking. I'm just reading a book by Daniel Ellsberg, the guy who revealed the Pentagon Papers about the Vietnam War. And he worked at RAND, where I knew many people who were working. And why was RAND Corporation, which was a think tank, so dangerous? It was so dangerous, says Daniel Ellsberg, and I agree with him, because the knowledge they had was terribly restricted. And the great thing about the things you're talking about is how widespread the ability to tap into that knowledge is. The knowledge that Ellsberg found that the RAND Corporation had was that deterrence could be improved to the point where you could actually kill not 1 million people, but 1 billion people. You're not mishearing. And when they looked, if there had been wider debate, they would have found that out earlier, but there wasn't. And so nobody pointed out, your model doesn't include the effects of fires in the nuclear war. It doesn't include the effect of smoke and so on. That's where we need wider discussion. And so whenever you think about regulating discussion, I think you should come down on the side of widening access to knowledge. If that means a bit of fake news, so be it.
I think with that, I think it's an excellent place to end. So I'd like to thank our panelists, Charu, Mukti, Ludovic, and Jonathan again for we have some coffee outside for about half an hour. We can all mingle and chat while we get the room set up for the next panel.
We have a second panel in the second half.
Thank you very much.